Personal computers in a networked environment don't just magically communicate or use some kind of PC telepathy. They actually require a physical connection of some type in order to be able to communicate. The most common type of connectivity is called a cabled connection, and there are a variety of different methods, connectors, media, and so forth that are involved in accomplishing this. Some are quite a bit in the past, and others are much more current and present. Because you may encounter these legacy type of environments, it's important to be aware of them, as well as knowing how to work with the current, modern, everyday type of methods that you'll see out there now. Let's take a look.
The first type of cabling we want to look at is coaxial cable. This was the first type of media used for networks, and there is still an aspect of it used today. Coaxial cable is actually an electrical cable with an inner conductor surrounded by a flexible insulating layer, which you actually see here. The insulating layer is surrounded by a braided shield, which then has a protective casing. Now, there are a lot of implications for dealing with coaxial cable. If there's a cable cut, the entire network is brought down. If terminators are used, which on a coaxial cable network was required, removing a terminator will actually bring the network down. Terminators actually were on both ends of the cable in order to close the circuit. If you had to remove a computer, for instance, in what was called the 10-base-2 network, or thin net we'll talk about in a moment, it would also bring the network down. You also had radio frequency interference, RFI, and electromagnetic interference, or EMI. We'll talk a little bit about some of the different types of cabling when it comes to coax. So one of the things to understand is that in this environment, it's a bus type of topology, meaning every device was physically connected to that single cable. And so again, when you remove a device, you remove a terminator, you open the circuit in any way, it brings the entire network down. It uses the popular F connector that you're probably familiar with when it comes to cable TV or cable internet. Now, there are several types of coaxial cabling and networks. The first and the oldest is called 10-base-5. It's sometimes referred to as thicknet. It used a very thick type of coax in order to be able to provide connectivity. And again, it was a bus topology. You had to have terminators, as you see here, and they used what was called a vampire tap, where you actually took this device and it would bite down into the cable in order to provide that type of connectivity. Obviously, you could think of over time that could be rather interesting if you put enough vampire taps on the cable. But this is the way that original connectivity was created, using these vampire taps, using thicknet. Later, as the technology progressed, a thin piece of coax, a lot more similar to what you've seen in cable TV installations, was pioneered, called 10-base-2. Incidentally, the 10 in 10 base meant 10 megabits per second was the maximum. And then base 2, in this case, it was 185 meters that it was able to go. That's why it was 10-base-2, meaning basically 200 meters. And then with 10-base-5, it had a limit of 500 meters. But it's essentially the same system, it's just with thinner coaxial cable, which made it easier to deploy. Now, one of the things about the BNC connector that you actually also see here, it's actually a twist-on type of connector. So coaxial cable, again, used extensively in the early years of networking, not really used typically now. As cabling technology advanced, coaxial cable was superseded by another type of cabling called twisted pair cabling, which is still in use today. These are the copper type connections that are used to support most networks. When you buy patch cables or Ethernet cables, these are twisted pair cabling. So let's take a look at what's involved, because this is definitely very relevant and current today. So let's talk a little bit about the types of twisted pair. There are two primary types. There's shielded twisted pair, sometimes called STP, and you actually notice you see the twisted pairs, and then you actually see a foil shield around there and a grounding wire as well. This was used in token ring networks and in some early twisted pair networks. Then you had unshielded twisted pair. Notice, same basic type of cabling, no ground wire and no shielding. And this is typically what is used in most networks today. Incidentally, the reason the wires are twisted together is the electromagnetic type of dynamics actually will help the signal to go further when they're twisted in that sort of way. So it actually helps the signal travel further. And this is the basic cabling technology, again, that's used in networks today. There are different ratings of speed for twisted pair, however, specifically unshielded twisted pair, which is what we're going to be talking about in the rest of this. And it's important to know the different types of cabling within the twisted pair family and what kind of speeds are possible. So let's talk about the speeds that are available. We have this little speedometer, very similar to what you would actually see on your dashboard in your vehicle, either a tachometer or a speedometer, but it gives you an idea in terms of megabits per second of what kind of ratings we're going to be looking at from a speed standpoint. So the first, we actually have Category 3, or sometimes called Cat 3 cable, which is Category 3 unshielded twisted pair. And this is essentially telephony grade cable. And you can actually get about 10 megabits per second for Ethernet connectivity using Category 3 unshielded twisted pair. You're not really going to be able to get much beyond that because of the type of construction and twisting type mechanism that's in Category 3 or Cat 3 UTP. Next you have Category 5 or Cat 5 UTP. This is actually rated for 100 megabits per second Ethernet, or what is sometimes referred to as fast Ethernet. Very, very widely deployed in a lot of networks. Many times between the desktop and whatever the network infrastructure is, you're going to have this type of connectivity. Then you have what's called gigabit connectivity. At this point, you're going to be using Category 5E or Category 6 unshielded twisted pair, which gives you a maximum speed of 1 gigabit per second, which is much faster. Much more widely deployed, and as costs have come down for gigabit switches, these have become much, much more broadly deployed. Now, as we've talked about the type of cabling, the speeds that are capable, and so forth, we want to talk about the types of connectors that are used. First, you may see the RJ11, which stands for registered jack, and this is actually the type you're going to see in your telephone type of deployments. Typically, this is going to be analog phone cabling. Then you have the registered jack 45, which is what you're going to be using for UTP cable or Ethernet. Now, another type of cabling I just want to mention here is what's called plenum rated cabling. Usually the space above the ceiling, when you have suspended ceilings, facilitates airflow throughout the building, and you can actually put cabling there. And what plenum rating cable does is it can be installed there, and it has sort of a fire retardant outer casing made of PVC. And non-plenum rating cables should not be used in the plenum area because of the type of fire risks that can be had. So here you actually see the pins that are on the RJ45 jack and plug, respectively. You can see the way pin 1 and pin 8 is oriented. And this is actually a crimp-on connector, which you can actually put on the end of a cable. You have to make sure the correct wires and pairs are in the positions that they should be. And this is the basic pattern. And there's two types. There's T568A and T568B, and they actually have slightly different types of deployments when it comes to the cabling. We actually have a handout that accompanies this lesson that gives you a little bit more detail. But this is the T568A type of designation, and you can actually see what wires typically are put on which pin. If there's ever any confusion, it's good to know this to be able to check, because I've seen a number of occasions over the years where there's been a mistake in crimping the cable, and therefore it didn't work correctly. Ultimately, if you make the same mistake on both ends, it'll work, but it might be a little harder to diagnose. Now, we had actually mentioned maximum distance when it came to coaxial cable, the 200 meters, 500 meters, etc. But with shielded twisted pair, with Ethernet, you're generally going to have a distance limitation of 100 meters. So what do you want to do when you go beyond that? Well, you can put repeater devices in between. They can be problematic. But typically, in order to be able to eliminate electromagnetic interference, as well as being able to go longer distances, you're going to use the fiber optic cable. And this is very important in a lot of networks today. It's essentially spun glass that allows you to be able to send light signals. But let's talk a little bit about the architecture of fiber optic cabling. A fiber optic cable is actually going to contain one or more optical fibers. Each fiber is actually surrounded by a protective cladding, as you see here. This is in order to be able to keep the glass core from breaking, and then that cladding is protected by an outer jacket. And what fiber optic cabling actually does is light pulses are transmitted representing ones and zeros, and these pulses represent obviously data. One of the great benefits to fiber optic cabling is it's not susceptible to either EMI or RFI, electromagnetic interference, or radio frequency interference. And it's not like someone can just simply use something of the equivalent of a vampire tap to be able to easily eavesdrop on the line. The other aspect that's very positive is it can go much greater distances depending on the lasers that are used as part of the infrastructure. Now, there are several different types, specifically 2 fiber optic cable types. The first is called single mode fiber, sometimes called SMF. You actually see the representation of a fiber optic cable here. Single mode fiber actually has a single path of light. Because of the way the cable is constructed, there is essentially one path of light going from end to end, straight across and through. Single mode fiber is generally more expensive. Then you have multi-mode fiber, or MMF. And as you can see, the light bounces around various parts along the fiber and actually creates multiple paths of light. Much less expensive, but not necessarily as efficient. As you might suspect, there are a number of different types of fiber optic connectors. The first is called the FC connector. This is basically a screw-on type of connector. I've actually used these in installations. LC, sometimes referred to as little click because you simply push it in and it clicks. ST, which is another type of basically twist and click type of fastener. An ST is sometimes called stick and twist. That's the easy way, the ST, because it also screws on. And then SC, which is actually sometimes referred to as stick and click because you push it in until it clicks. In most situations, you're going to be seeing just about all of these types of connectors. And then there's also the toss-link type of connector, which you may not likely encounter, but you need to know about its availability and awareness.
Now, we've been talking about network connectivity to computers and other devices. One of the things that we talked about was Ethernet, or cabled connections. Now, I wanted to actually show you an Ethernet cord and connector. This is actually an RJ45. There's a little bit of a difference between this and the RJ11 that you may recognize on the phones in your house. This one's actually twice as wide, and you obviously can't use them interchangeably. But in this particular case, you have the RJ45 plug that actually goes into the jack on the back of the computer, and we're actually going to show you how that works now. We have our RJ45 Ethernet connector. You'll notice on the adapter there's a link light and an activity light. If this were plugged in, you'd actually see the link light go in when I connect this, and the activity light begin to flash when traffic is flowing. But pretty much it's just a matter of taking that RJ45 and plugging it in until it clicks, then obviously taking this and putting in some networking device. And when you want to remove it, you simply press down on that tab and you pull it back out. And that's how simple Ethernet connectivity can be.
So just some terms as we summarize fiber optic cabling. You have RG6, which is the coaxial cable most commonly used for cable, television, and satellite installation. It uses the F-type connector. There was also RG8U and RG58U, which is actually for the thin net and thick net, respectively. So there's a number of different types of coaxial cable. You'll actually see this in your handout. UTP, unshielded twisted pair, by far the most common copper cabling used in modern Ethernet networks. Pairs of wire are twisted in order to enable the signal to travel farther. And in general, your Ethernet limitations, distance-wise, are going to be 100 meters. Next, you have RJ11, registered jack 11, commonly used on 4-wire plain old telephone service, POTS, analog connectivity, to the central office of the telephone company. Then you have RJ45, registered jack 45, very commonly used to terminate unshielded twisted pair cabling for local area networks such as Ethernet.
Now that you've had a chance to take in the different types of cabling connectors in this particular lesson, you should have a pretty good grasp now of how it all works. You should be able to have a great idea of the best methods to recommend, and without intending to sound like this is a pun, you can help users connect with their data in order to be able to accomplish these types of things. This can give you a real edge as you're out there in the professional work world to make the best kind of impression for yourself and for the industry that you represent.